Joe, can you see the presentation?
Yeah, it's great.
Okay, cool. All right, so let's get right to it. So today's webinar is how to reduce the cost of quality with Industry 4.0. There you go. So the goal of the webinar is really to become acquainted with Industry 4.0, with Quality 4.0, learn what those mean, understand how manufacturing apps, what they are and what their impact on quality is, and how you can use manufacturing apps to really reduce the cost of quality, and get a broad understanding on how manufacturing apps can help reduce that cost of quality as well. I just want to say that during the webinar, if you want to ask any questions, there's a widget on the GoToWebinar software that lets you ask the questions. And we'll have time at the end of the presentation to go over some of those questions, but feel free to ask them throughout the webinar. We'll try to leave 15 to 20 minutes at the end to go through some questions as well. And after the webinar, we'll send you a recording, so you don't have to be worried about taking notes or anything like that. But anyways, we have a lot to cover, so I'll get to it. Let's start about, talking about what is Industry 4.0, right? So Industry 4.0 is what it's been called the fourth industrial revolution. But to understand it, we should really begin with with the history of it, right? So the history starts with the first industrial revolution, and all industrial revolutions have had an enabling technology that has changed the way we make things, right? So the first industrial revolution in the 18th century had steam power as the enabling technology, and it changed production because it now allowed for mechanical production, right? Then sometime after that, in the 19th century, we have a new enabling technology coming in this case, electricity. And that allowed us to change the way we manufacture and start adding mass production, right, and assembly lines to our factories. Move forward sometime in the mid 20th century, and we have information and communication technologies, automation, really changing how we produce with automation and network production. And that takes us to the present, right, with the so-called fourth industrial revolution. The enabling technologies in the fourth industrial revolution are cyber physical systems, what's usually called an Internet of Things, networks. And the way that's changing production is really bringing it from a hierarchical system, from a top-down system, to a more emergent system that's intelligent, flexible, self-organizing in a way. And we'll go deeper into these concepts later throughout the webinar. We could really have a whole webinar just on Industry 4.0, and maybe we'll do that sometime in the future. But I think the main point is, one of the things that people often ask us is like, what is really this Internet of Things? And I guess there's a couple of ways to explain it. The first thing is that it's not a separate internet. There's no such thing as an Internet of Things and a regular internet. There's just one internet. But what IoT usually means, what the Internet of Things or industrial Internet of Things usually means, is connecting devices to the cloud and having them interact with each other. So in the case of consumer products, that might be if you have an Amazon Alexa at home, that's connected to the cloud. If you have a Fitbit, that's usually thought of as an IoT device as well. Or if you have a Nest thermostat or something of that sort. Those are all examples of consumer Internet of Things devices. But in industrial settings, in manufacturing, that translates to having your machines. They can be legacy machines or newer machines, your tools and sensors connected to the cloud, talking to each other. And that completely changes the way we think about systems in manufacturing. Right, but okay, enough of Industry 4.0. I guess the main point with all of this is that these different enabling technologies have changed production as a whole, but they've also changed quality and the practice of quality. So to go over that, I'm gonna hand it back to Joe to take us through that process.
Sure, thanks, Saul. Very few people have ever lived in all three centuries, but our founder did. being from the late 1890s, living right up until the early 2000s. So you could figure that one out. But if we take a look at the changes that have taken place in industry, 1, 2, 3, 4, it's also obviously either led or simultaneously caused us to look differently at how to manage for quality. So if we think way back to the steam power, most of quality management had been in most of production was really craftspersons making things. We didn't see mass production until the 2.0. So in essence, quality management at 1.0 was really self-inspection. The craftsperson would make their things and then they would check it. And actually, we had pretty good supplier customer relations because we were the supplier. We were dealing with customers. As industry became more mass produced, and you'll tend to read about the history of quality, and you'll see things related to Taylorism, and that the mass production, although it made us very productive, actually impacted the way the self-inspected quality was. And so we started to add quality control, quality assurance, and continued more inspection by a second person or third person, because no longer, if I were the craftsperson, I could keep up with production. So I hired people and our factories grew. And then late into the late 19th century, we started to get World War One. World War One, World War Two, and that started to cause military standards to come about, which drove another level of quality management system. By the time we get into the most recent 20th century, uh, I would say prior to the last 10, 15 years, quality has been driven mainly from uh, software that helps us manage the documentation, that helps us do project management, that helps us get information faster, and it has helped us manage the cost of quality, and it has added to the cost of quality in a positive way. The impact today, and I made some radical statements, although they're not so radical, that this technology and the Internet of Things is really causing and will cause a big change in how we manage for quality. Because most of our prior quality management systems were based on quality control and quality assurance. And if we can get a much better handle on quality control and quality assurance, or we have much less defect, we don't have to do a lot of that. And we could shift our attention. So what we're going to talk about here today is the impact of Quality 4.0, or the creation of Quality 4.0, what it might mean to quality management systems, and how you should be thinking about it. I always go back to helping people understand what we mean by quality and quality management system. If quality is the goodness of your product and service that you deliver to your customer, and it conforms to their need, when it doesn't conform, we have to act on it. So if you look at this graph over time, in essence, what goes up is bad. And at time zero, where my horizontal and vertical lines meet, our organization is operating at some level of variation and some level not exactly perfect above perfection. And we tend to manage that through quality control activities. And those control activities could be quality control, quality assurance, conducting basic root cause analysis, doing basic statistical process control and the like. At times, we have a sporadic spike, and that sporadic spike will lead us to do some corrective action, but we maintain that level of performance. But over time, we recognize that that level of performance isn't good enough. Matter of fact, it includes a lot of cost of poor quality, the cost of nonconformance, in other words. And that cost of nonconformance shows up as an impact to our bottom lines in companies. It takes away profit. It could also take away sales. Why? Because the goodness of the product is not meeting customer requirements, and therefore we have to spend more money to correct it. Or we have to redesign and add features that would satisfy the customer further so they buy it. So in the program, and that continuous improvement program typically looks like some kind of breakthrough improvement. And we chip away at that level of conformance down to a new level, at a much better level. So on that one hand, we have quality of control, quality of improvement. And as we get better and better at those two, we have more time to spend on quality of design. And therefore, we could spend more time creating new products, new services that benefit the customer. Now, in most of your organizations, particularly if you're in manufacturing organizations, the amount of complexity in our organizations related to the quality management system still reside in quality control, meaning that we try to maintain the level of performance that we designed in and periodically improve it. Now, as we advance our thinking, another way to look at this quality management is that even though we keep getting to new levels, we have to continuously improve, we have to continuously control. But where our labor is and where our activities are, there's still too much of it in the control level, which is contributing to the cost of quality in a way that if we had a different approach to it, it might reduce it. We'll take a look at the next slide. So I'm going to use this term cost of quality. Cost of quality really is the additional costs that we spend to prevent failure, like design reviews and design and planning, understanding voice of the customer, teaching our employees the importance of customer requirements, understanding what's critical to quality, and establishing good process control of them. We also spend money on appraisal, inspection, testing, audit, assessment. These are things that we do just to make sure before the product is delivered, it works. So we can refer to those as somewhat positive costs or the cost of conformance. Unfortunately, there's also a cost of non-conformance, and that are the failures that we have every day. You can call them quality defects, quality deficiencies, anything that does not meet the need of the customer and we have to fix it, or does not meet the need of the business and we have to fix it. And some of those we fix in-house, and some of those they get out, they escape, and we have to fix them outside. So our industry thinks about cost of poor quality as the internal and external failures. You add that to the prevention and appraisal, you get the cost of quality. Now, I'd like to explain, when we talk about continuous improvement, quality improvement, your Lean and Six Sigma, they're all trying to go after non-value added work. And a lot of that non-value added work is typically seen in the fixing of failures or the root cause analysis of failures, or low productivity due to too many steps in the process, or if you're understanding the 7 deadly wastes in an organization. What we've tended to focus on is to try to prevent these as much as we can, but we probably over time are spending too little or too much on some of these. Here's a way to look at that. Let's say that in purple, we have our total cost of operations. That could be our total cost of goods sold. It could be our total cost in the organization. The point here is that once we have our total cost, what's left over is profit. Now, if we take a look at what's inside that cost of operation, we have some of this total cost of quality. And that total cost of quality is the money we have to spend to make sure we meet the customer requirement. And our profit is X. Now, if we look deeper into that cost of quality, you'll see these 4 breakdowns of internal failure, external failure, appraisal, and prevention. And as you take a look at that, you'll notice that the majority of that is in the failure costs. And most of our time spent in quality management, that is quality control, quality insurance, is appraising our process to minimize the chance of internal failures and possibly external failures. In the event of external failures, we have to do root cause analysis or CAPA and correct that. So we spend some money on prevention, some money on appraisal. Interestingly, as a total cost of quality, that total cost of poor quality could be 15 to 25% of the total cost of operation, with 60 to 70% of that being in the failures. So there's a big opportunity to reduce those failures, which we have been working on with various Lean, Six Sigma, continuous improvement efforts. What's different about Industry 4.0 and the Internet of Things, we're not only going to be reducing the failures, but due to the technology and real-time data and sensory devices that maintain process in conformance, we're also going to be minimizing prevention and appraisal costs. So now you can take a look at this same scenario. If this was the same company, our total cost of operations is lower, our total cost of quality is lower, and our profitability is higher. And I could give you thousands of examples of organizations that have chipped away at the cost of poor quality and have been very proud to get 8 to 10% of their total cost of operation as cost of poor quality, but they might be getting it at an enormous amount of appraisal and not enough prevention. So the impact of this digitalization is having, and you're going to see some examples from Tulip and Saul, is having an impact on the quality management profession. And if you think back to my example of quality planning, quality control, and quality improvement, we're going to shift a lot of the attention from third-party appraisal and inspection to more improvement and more planning and more design, which is actually a better thing to do. So now, how do we get cost of poor quality? And before I turn it over to Saul, if you think about a process as a bunch of steps like these in blue, whether the input is coming from a third-party raw material manufacturer or a third part of your business or some kind of information provider, we get input from someone. And we want to make sure that input is good. So we might have incoming inspection, we might have some tests. In other words, we look at what's critical to quality, and we make sure it's good before we process it. And at each step along the process, we not only know what's critical to quality, but we monitor what's critical. And if we're not meeting our requirements, we take action. We also have work instructions that are either in paper or in computers or in training classes or in binders that tell people how to operate when things go well and how to act when things don't go well. And this is pretty much a process in a state of control today. We have operators and people working in a process, and we typically have a third party, another group of people, the quality folks, or people in operations doing the role of the quality folks, checking to make sure we're in conformance. Now, if we take a look deeper at the gray buckets here, you'll see what actually happens and why the digitalization is going to be beneficial. When we have something that's critical to quality, say the weight, the color, the diameter, the size, the humidity, the temperature, each of these are metrics or measures of performance that collectively meet a requirement to make the product meet the customer requirement of what's important. Each has its own target or baseline, and we can monitor that baseline to understand the normal variation. And we tend to set spec limits on that. And then we carry out routine testing and monitoring where we collect data, compare it to the standard, and if it meets the target, we keep things moving. If it doesn't meet the target, we take action. In today's kind of somewhat digital systems, it's possible that you have some automatic data collection devices. It's possible that some of you are very sophisticated and that automatic data collection devices actually then goes into some automatic data analysis devices. But there's still pretty much people that have to collect data, find the right data, analyze the data, and take action. Tends to take time, tends to take productivity away, and it tends to remove the operators from a state of self-control. So if we could find a better way to monitor actual performance, compare it to the standard, and alert us to take action much sooner, we could maintain a process to almost a state of zero defects. And Sal's going to show you some examples of how that happens. And then I'm going to come back and I'm going to summarize a little bit what Sal showed you. Take it away, Sal.
Thanks, Joe. So we've been talking about how digital tools like manufacturing apps and other technologies from Industry 4.0 can help with this, with the quality management, and it can help reduce appraisals and the costs associated with it. But before we go deeper into how that works, I guess let's take a step back to define what are manufacturing apps, right? So Manufacturing apps are really just applications that turn your workflows into instrumented data collecting digital processes. And I know that's kind of a mouthful, so we'll unpack it. But the way to understand it is just like software in your computer or on your phone, the apps can help manufacturing workers be more productive. Just like the apps that you currently use on your day-to-day help you be more productive, these apps can help you be more productive. But there are differences, right? Because the apps or the software you usually use on your day-to-day is built to do one thing or a couple of things, but it's not flexible. You can't really tweak it and bend it to do other things. With manufacturing apps, on the other hand, you can, and we'll go over a couple of examples of that. But the reason you can do it is because you can easily create, test, deploy, and iterate over those apps on your own, right? So we'll go over some examples later, but that ability to build the apps yourself is very important because it just speeds up your continuous improvement processes. Now the apps are also, like all apps, they're visual, so they have user-friendly interfaces. They are IoT enabled, so they can connect with your devices, with your machines, with your tools. They are data-driven, so they collect data as people use them, and they have interactive logic, so you can define different decision trees and different paths that would happen as people interact with the apps. So the main point is that they are, they're a technology that incorporates several elements of Industry 4.0, including IoT, big data, cloud computing, and others. So let's go back to Joe's example and examine how the apps change this process, right? So whereas before you were running the manufacturing process with work instructions or paper-based processes, you can use apps to really drive that process now. So as you can see on the screen, you can digitize the process and guide the workflow. As people use the process, you can have the critical to quality variables be automatically collected, right? So you can leverage different IoT devices. In this case, for example, on the first step, you might want to use a barcode scanner to make sure that the part you're building is the right part, or make sure that it connects with your ERP so that you're building the right order for the customer, or whatever you want to use the barcode scanner for. You could also use, say, if your operation requires certain levels of temperature or humidity, you could use sensors for those variables that are constantly monitoring your operation. And if a variable hits a certain threshold, then you can use the logic behind the app to activate a certain event. So for example, if you need the temperature or the humidity to be within a certain tolerance, when that tolerance is passed, then you can have an email, for example, or a text message go out to the supervisor of the line. Or you could have the app guide the operator through the quality loop and whatever you need to do in order to get those values back within range. But the point of this is that the app is constantly monitoring your process and guiding it. So it's much faster to catch defects and to catch deviations. So it makes the process of fixing that also happen much faster. And the point is, as the app monitors the event and guides the manufacturing process, you're collecting data that is now real time. So without this kind of systems, your data is kind of being collected manually with a pen and paper and maybe a stopwatch, or you're doing other types of sampling with other types of devices, but you're collecting all that data manually. So by the time you get to the analysis, that data is already stale. It's already no longer relevant. So with apps, that is no longer the case, because they're always kind of monitoring your operation. So let's just see one more, another way of looking at this is taking any shop floor process that you want to kind of guide and control for, using manufacturing apps to control it with IoT and the real-time production data to optimize and improve over time. So let's take this back to Joe's original Juran framework. And Joe, if you want, can you hear me, Joe?
You disappeared for a second there.
Oh, okay. There you go. Sorry about that.
So if we think about the examples that Saul just used, if we had better real-time sensory, real-time data, and you could see it happening on the voice of the customer side, a lot of organizations are collecting all this data from the internet and understanding customer and consumer behaviors, and then turning those behaviors, information on behaviors in real time into minute by minute customer service and customer experience, and then helps us design products as well. Similarly, we get direct feedback from some of this input, and we can maintain performance. And at the same time, you notice in some of the graphs there, if you saw it, that the data collection and data analysis, if you were collecting the data and it was plotting it for you in real time, and if it was also controlling a piece of equipment, you can see how the benefit of breakthrough is going to happen. And so these apps and technology, as Saul will point out, can help us can do better control, better improvement, and better planning. Back to you, Saul.
Yeah, so I mean, the point of this is that as you're using the apps to kind of digitize your different processes in your shop floor, in the end, what you're doing is turning your quality management system into all these different apps. So if you're using apps to run your work instructions and your quality inspections, in the end, what you're ending up with is with a digital QMS that's just much more efficient, as Joe was saying at the beginning. And we'll go over some specific use cases, but some of the things you could do is, rather than run a quality inspection manually, you can now build an app that walks your operators or your team through the quality inspection so that you collect data about the inspection. Or if you're running audits, right, you could use apps to kind of digitize those processes and ensure that when people are actually executing them, but then you could also gather data on who executed them, when, and so on, so that if something fails down the road, you can have more traceability and more granular understanding on what's going on. And the same with machine maintenance operations or part samplings. The point is that when you bring your processes, when you digitize your processes with manufacturing apps, you're kind of marrying the two, the quality and the manufacturing operations into one, with all the benefits that we discussed before. But I guess the easiest way to really understand what this does for like real operations is to go into some real world examples. As I mentioned at the beginning of the webinar, Tulip is a manufacturing app platform. What this means is that you can use our platform to build this type of apps. You don't need to know how to code. You don't need to be in IT in order to do this. It's all drag and drop. So you can define what these apps look like. You can define the data they collect. You can define the logic behind them, and you can deploy them and iterate over them much faster than you could with any other system because of this self-serve nature of the platform. So let's go over a couple of examples. The first one is a faster root cause analysis. So I'll go over a customer of ours. They make shoes. So the way that we're doing quality inspections before is with something like what you see on the screen right now. So it's a clipboard with a paper form and a picture of the product. And they have certain things that they need to check in that product, right? So the inspection operator would need to check those things before the product gets shipped. They need to record data on this clipboard. Eventually, that data would be transferred to Excel, so they can have a digital form of this data to perform analysis and to share with other stakeholders. But it was actually only used once a quarter on the quarterly reviews, and collecting all this data in the paper and then transferring it to Excel, and all that process took a quarter of the engineer's time, of the quality engineer's time. So what they did is they used Tulip to build an app that kind of digitized this whole process. So on the right side of the screen, you can see kind of a screenshot of what that app, like what that paper-based process looks like as an app, right? So you have the same picture of the end product, and you have different, all the blue dots are points where they need to check for defects. And as they check for defects, they can click on those things. In their particular case, they have these on tablets, so they can actually, touch the screen, click on one of those dots if they need to report something. And then as they're using this app, the data is made available in real time for all stakeholders. So you see there a picture of one of the dashboards they deployed on their operations, where they can see the defects being reported in real time, and they can see what's causing the defect. They can catch those defects much earlier and do faster root cause analysis. Whereas before they were doing review on this data on a quarterly basis, now they can do this on on real time pretty much. And the point is that you have scrap and rework data collected in real time. You have continuous reporting for everyone, and this just drives more accountability throughout the shop floor, because now you know who is doing what in real time. And what the different effects are on people's different assemblies. So the bottom line in this particular use case was a 96% reduction in rework, 68% reduction in scrap, and the quality engineer's time was saved. A quarter of his time was saved after implementing Tulip. So this is one of the examples where you have faster root cause analysis with this real-time data that you wouldn't otherwise have. Another example is, this is from GE. They're another customer of ours, and they are using Tulip to kind of digitize their work instructions. So you've probably seen work instructions like the ones on the left here. So it's paper-based. You have some pictures with some, commentary on top of them, showing them the workers what they need to do. But the problem with these work instructions, as I'm sure many of you in the audience know, is that, well, first of all, nobody really follows them. Nobody even knows what's the latest version in most cases. At least that's what we've seen. So there's no adherence to them. You don't know if people are following them. If you're following this type of work instructions, you're probably being slowed down, right? So maybe you're not making mistakes, but either way, you are slowed down because you have to go back and forth between the instruction and your process. So what GE did is, with Tulip, they built apps that digitize that whole work instruction, but rather than just making a digital copy of them, they integrate with IoT on their shop floor, on their line, to error-proof the assembly process. So what you see on that picture is you have all these different bins of the different components that the product uses, and if you see where the hand is picking, there's a light coming out. So that's a Pictolite. It's an IoT-enabled Pictolite that connects with the Tulip app, and basically it lights up when you're supposed to pick from that bin. And there are also some break bins there. So if you're picking from the wrong bin, you'll get a big red light basically in your face, so that you can't make mistakes. And after doing this, after using this, they saw defect rate go down by 98%. So, I mean, it had other impacts as well. Like they were going through the flow faster because of this reason of not having to go back and forth between the instructions and having the most relevant information available at all times. And then also, of course, the training time was also positively impacted, because if you have this type of information in front of you, it just makes it easier for you to learn new processes, not only for new hires, but in general. If you're learning a new product introduction, or if you're learning a new, a different setup for the assembly line, you can just learn much faster with this kind of real-time information displayed. And the last example I want to go into, so we can have some time for questions, is an example where this customer of ours created an app to report on certain quality information that they needed to report. So before, they were doing this reporting with the forms that you see there on the left. This reporting critical to regulation and so on, and to their internal protocols. But the problem is that you have a lot of transcription mistakes, right? Because, I mean, in the end, what we're dealing with is you can have a great process, but humans make human errors, and the idea of using apps to guide these processes is to kind of minimize the errors. And in this case, this customer actually completely eliminated transcription errors, because rather than have people fill out forms, by handwriting, they could just create interactive forms through embedded in the apps themselves to kind of automate that data collection process. And depending on what you're manufacturing, this traceability is very important, right? For certain industries, it's actually key, and it's a regulatory kind of table stakes. So with this type of apps, you are actually collecting data on who worked on what parts, what materials they used, and you're ensuring that the data is accurate. So, with those examples, I guess it's a good time to bring it back and kind of summarize what we've covered throughout the webinar. Joe, I don't know if you want to add anything to the use cases, or if you.
Well, I'd like to just point out to our participants on this webinar that, if you're in a manufacturing organization and you're asking yourself, well, where do I put a flat screen, or where do I put a handheld device? Or if I'm in a non-manufacturing and I'm like, I work in an office area, how does this apply to me? The best way to think about that is that if every employee came to work and on their own iPhone, it told them what the process control was, what the requirements were, in real time how you were performing, and if there was a new application, you could literally say, hey, Google, tell me how to perform this operation, and the screen comes up. So the one thing about the technology is the investment can actually be low if you tap into all the PDAs you have. On the other hand, I've seen some really grungy manufacturing areas with high-tech flat screens because in the long term, it was the cheapest way to go. So I don't want people to think that you got to have an elaborate amount of devices there. So just a point of interest to look more deep into if you want to know more about it. So here we are. So if you think about going from industry 1, 2, 3 up to 4 and how it's impacting quality and the cost of quality, literally the cost of setting up manufacturing apps and the Internet of Things is still cheaper than inspection, over testing, over auditing, maintaining documentation, and all that. Why? Because without apps, data is collected sporadically, used when it's ready, and it's already outdated. That data could be in real time, so you can get it faster, less costly. Information sharing. How many times have you tried to get, whether you're trying to do a continuous improvement or trying to audit a process or trying to maintain control of a process, where's the data? Someone owns it. Someone's keeping it. You have to get it. You have to get it in a way you want it. When it's in the cloud, accessible to everyone, the stakeholders can get it when they want it to maintain performance. That Monday morning meeting, the Monday morning meeting, I call it. Typically, factories have them once a week. Some have them once a day, 15 minutes. Says, let's talk about what went wrong last night. Let's talk about what we're doing today. Well, the Monday morning meetings can shift from what went wrong to we had perfect production last night. Let's talk about how we can increase our production because we have the demand higher. Very different conversation focused on improvement rather than control. When you minimize the amount of audits, tests, appraisals, inspections, the excess of training because the training is coming real time, you can then have less of that, and therefore your cost of prevention and your cost of appraisal goes down. Why does it go down? Because the amount of time you need to spend on it is less because you have less defects to worry about. And then my most important one, I'm in the in our business is about education and training and certification for folks. We're seeing organizations improve the skill levels of their operations folks through the use of this real-time learning and real-time technology. Think about this. If you're sitting around and someone says, "Hey, how old was that actor?" and boom, what do? You Google it. Or someone says, "Is there a research paper on this?" Boom, you look it up. Skills are learned faster, quicker, and in smaller bites, which is exactly what a smart worker wants, is to have little small bits of information easily at their disposal to keep things moving rather than have to stop, start, or go to a classroom and come back. Even in our industry, the use of technology is dramatically changing the way learning is done and the way coaching is done. So if you haven't thought about manufacturing apps or don't know much about it, I suggest you take a look at some of the trendsetters out there like Tulip. If you don't understand how to marry the relationship between manufacturing apps and cost of poor quality or cost of quality and your quality management, you can reach out to us, of course. So Saul, I turn it back to you.
Thanks, Joe. So I guess let's take some questions. We've been getting, bombarded with some questions here. We have some time left. So I guess one of the questions I see asked more is what kind of technical knowledge and skills do you need to build in order to build and use these apps? So I guess that's a very good question. The answer, I guess, depends on what you're using to build those. In the case of if you're using something like Tulip, for example, that's a no-code platform, the amount of technical skills you need is absolutely none, right? So if you can build things like PowerPoint presentations, you can build apps with Tulip. So I would say, depending on the provider you use, that level of skill could vary. But in the case of Tulip, it's very minimum. It's all drag and drop. It's visual. It's a visual environment where you can define how the UI looks for your app. You can define the user interface. You can define the logic without really having to write any code. Another question I'm seeing here is how do you control the changes and permissions on the apps? And that's a very good question. We get that asked very often, especially when we're talking with quality folks. So I mean, like any other software, you can define roles, right? So you can define, you can give people access to the apps. You can let certain people edit the apps. You can control the version that's running on the shop floor. Just like you could with with other with documents, for example. You could give different levels of permissions for different people in your manufacturing facility. Let's see, what else do we have here? So this is a question, Joe, this is a question for you. So it says, Joe, how do you see this manufacturing app work in high volume and batch production? In most applications, we don't need to collect data on each piece. Does the app allow you to enter completed lot quantities and collect data intervals? This is from Randy from Watson.
Hi, I think that's a really good question. It's the same question we get now when it comes to sample size. So if you think about a process and you think about data collection from that process, we're still going to set it up based on a sample that helps us perform properly. So in other words, you don't have to have the instrument constantly running. It could be set up on a sample base. It could turn on, turn off, or it could just collect data when you want it, when you don't want it. That's the nice thing about constructing your own app, because over time, if you go back to my graph, if you think about it, you're trying to improve the variation day to day, batch to batch, week to week, but you're also trying to improve that level. So as you get better and better, the frequency of testing, the frequency of sampling, the frequency of audit should get less and less. So you can set the parameters. And if you think about this, I like to think about it like the Nest thermostat example Saul used. A traditional thermostat, you set it for a temperature and it maintains that temperature all day. A digital thermostat might have 2 or 3 times of the day. With the Nest thermostat, you could set it up 10, 12 different times a day to set upper and lower limits. Comes on and off, comes on and off, gives you more precise measure performance. And that's how the apps can set up your devices that way. And so as we have greater samples, we set it up for more collection, and less samples, less collection.
That's a great answer, Joe. We're getting another one here. I guess this is related to the point you made before about the devices and the IoT devices. So one question we're getting is, do we need to invest in the devices to collect the real-time data? What do you have to say on that?
Well, I was alluding to that a little bit, but we always have, when I talk to companies about that are trying to reduce costs, trying to improve productivity, and have various devices that are actually already sensory devices, and they're looking to spend hundreds of thousands of dollars on quality systems, I say stop, because, or I shouldn't say quality systems, enterprise solutions. I said, start process by process and take a look at a manufacturing app that can take the information you have. So on one hand, you're investing in an iPad or something. On the other hand, if you don't have that sensory device, do I have to buy them? Well, the reality is, however you collect your data now, whether you collect it from a third-party test or an inline sensory device, if you have an inline device, then create a manufacturing app to use that data. If you don't have one, create the manufacturing app to take what you have and simplify the data collection of it. So eventually you're going to have to spend money if you want real-time complete process control. In other words, I'm running a process step. I've got a sensor that's monitoring diameter, and as it varies from piece to piece, it then sends a signal to the machine to say adjust the machine to keep it in conformance. If you're looking for that level, you are going to have to make some investment into the sensors. But if you're looking for just quality management, then the amount of sensors could be a lot lower. But sooner or later, you're going to have to buy some measuring devices that are going to be capable, because that's what digitization is forcing you to do anyway. I hope that helps.
I related to that, Joe. I think like the key is that you don't have to go all or nothing, right? You can start pretty small. You can start with with just one variable that you want to measure, and if you see that working and you see the value that that's adding and you see the return on investment, you can start adding more to different kind of use cases in your operation. So it's not like an all or nothing where you need to go out and spend millions of dollars. Like, the beauty of this is that you can start with as one use case with one app, one or two sensors, and then scale it up as you go. So the risk level is much lower than than buying a new large piece of machinery, for example. So I think.
Yeah, I'd also like to comment on the sophistication. So I'm not that familiar with a lot of apps. I'm not a technology person like Saul and his company are. But in order for us to help our clients, we had to understand, is there a better way to minimize the cost of conformance? And it led us to folks like Tulip, and particularly Tulip. But the manufacturing application creation is it's almost like taking the Adobe Illustrator or a PowerPoint presentation and creating your own work of art. It's selecting from fields how I best want to take information and present it and use it. So the actual technology really makes it easy for whether you're a quality engineer, quality manager, a process engineer, or even just a supervisor on the line. You can actually get pretty good at developing your own apps with this kind of a platform. So the other thing about, you don't have to spend a lot on sensory, you don't have to spend a lot on design either. It's actually pretty good, and I think Saul's going to lead you to a link where you can take a look at some of these.
Yeah, I'll show a link later. We have time for a couple more questions. I'll just ask this one because I'm seeing a lot of people ask this about artificial intelligence and Industry 4.0 and how are they related and how they're related with manufacturing apps. I guess my take on this is that we try to avoid the whole artificial intelligence term because it's kind of become a buzzword now. Everyone's talking a lot about artificial intelligence, this and that, but in the end, what we see with our customers and with most manufacturing facilities that we visit is that the data just isn't there necessarily in order to do what you could do with artificial intelligence or machine learning. So we do offer those capabilities if you have the data, but most companies are not there yet. So if you don't have good quality data because you're collecting it, manually, and it's lagging behind your operations, and there's transcription errors and so on, then artificial intelligence doesn't necessarily add all that much value. If you're not having the data be collected automatically from your machines or your sensors and so on, same thing. So as long as you're not I guess you need to walk before you can run is what I usually tell our customers. I don't know if you have any thoughts around that, Joe.
No, I think you've summed that up pretty well, and I want to keep an eye on the time here. So
Yeah. So let's wrap it up. It's almost 3 p.m. So I wanted to thank everyone for joining us today. I wanted to thank you, Joe, more than anything. Thank you for spending some time today with us and sharing your expertise on quality and how you see quality evolving with Industry 4.0. We'll be sharing a recording of this webinar with everyone. And if we didn't get to answer your questions today, we'll do our best to follow up on emails or publishing some answers to the questions we couldn't answer today later in our blog.
thank you, Saul. Appreciate it.